So in this exercise, we're going to cover how to run an FIS error model. So this is exercise N part 1. So the first step is I've started a new ArcMap document here. The next step is I'm going to create a new GCD project, and I'm going to create that in the directory that I'm working in. So I am here. And exercises N, and I have a folder called FIS already, and I'm going to call that N underscore FIS just to stay organized. I'm going to go ahead and click OK, and then within your data folder, yours may be in a different location, but mine is in N underscore FIS intro. Got this raster here, DEM 2006 TIFF. So I'm going to load that raster to my GCD project. Navigate to that. Again, so N underscore FIS intro in the FIS folder. And I have this DEM 2006 TIFF. So I'm going to go ahead and load that. Looks like everything's dimensionally divisible. So go ahead and hit import raster. That all came in cleanly. So the first thing we're going to do here is we're just going to create a spatially uniform raster, or a spatially uniform error raster, just to make sure we understand that process. So I can go at it from two ways. I can right click here and say derive error surface, or I can go back, or I can say derive error surface here, or I can go to edit DEM survey properties and go over to error calculations. That's the way I'll do it. No reason for it, but I'll just do that one. I'm going to name this uniform 2006. Then I'm going to give it an amount. I'm going to make a 10 centimeter uniform, so I'm going to call it 10. You can use whatever nomenclature you want. So after I've named it, I then can enter in the amount that I want for the uniform error here, or if I had a survey method defined for this, then that would automatically be loaded here, and then I could manipulate it through the drop down. But I'm going to go ahead and just say uniform error value of 10 centimeters and go ahead and hit derive error surface. So pretty boring. If I were to investigate this, we'd see that everywhere it is indeed 10 centimeters. So I'll go ahead and leave that. So the next step is to load our 2-input and 3-input FIS into the FIS library if it's not already present. So it should already be present. The FIS library is located under the Customize menu, FIS library, and now there's a certain number of FIS that are shipped with GCD that we store in this Git repo. So the two that I will be using are this GPS Z error point density and slope degrees, and GPS Z error point degrees, slope degrees, point quality. If you visit this site here, there's a description of what all of these naming mechanisms are, and I would encourage you to do that just to get a feel for how we're providing these for you and some of the different ones that are available. If I did not have these automatically loaded, although they should, the way I would add an FIS file is to click here. I would navigate to where it is on my system, and then I would just go ahead and hit open and OK on that menu, and it would be placed here, which makes it available to my GCD projects. But I already have the two that I want that were preloaded, and that's how it should be by default. Um, so the next step is to derive the two inputs that I'll be using for my FIS. If you remember, I had the FIS, the two input is going to be point density and slope degrees. So to do that, I'm going to right click underneath the DEM that I'm working with and say add associated surface. The first one I'll add is slope raster. So we'll calculate that within GCD. And that's this button here. If you hover over any of these, they'll give you a description of what they are. And so this is calculate a slope raster in degrees. It says it'll be generated after I click OK. I like to give it a little bit more description. So I'm going to call it FIS 2006 SL for slope. I always use degrees, so or slope degrees, so no need for me to distinguish there from %rise, but so there's that. I'll go ahead and hit OK. The next step is to calculate the point density. So again, I'll right click on associated surfaces, and when we have this, calculate a point density raster from the DEM survey. So for this, we need the points that we use to create the DEM. Those are contained within your data folder for this exercise, so n_FIS intro. I have these surveyed points here. And I'm going to keep the default. You could change the moving window to different, but I'm going to keep it at rectangle. Go ahead and hit OK. And it'll automatically give it the type of point density. Again, I'm going to change this. But you're welcome to keep it as the default. And looks like all my inputs are set. I have the correct type. I've given it a name. I'm going to go ahead and hit OK. Okay, so that's my point density, and I've calculated my slope. The next step is I'm going to run the two input FIS using these two associated surfaces that I just created. So I'm going to right click here. Again, I could access this from the edit DEM survey properties, but I'll do it from this menu this time. First thing I'll do is I'll go over to this FIS error model, and all of the FIS that are loaded through this customize menu, FIS library, are available through this drop down menu. So I am going to use GPS Z error, means we're modeling Z error, point density, slope degrees, because these are the two inputs that I have. I will point it to my slope degrees raster for this input, slope dig, and I will point the point density to my point density raster. Then I'm going to give this a name. You don't need to be as explicit as I am with your names. I like to do this in case I pick a project up after the fact, then I'll know that this is in fact an FIS error model and it took slope and point density as its inputs. So with that set, I'm good to go. I've given it a name. I've selected the GPS Z error point density slope degrees FIS from the drop down menu, and then I've designated which inputs are represented by each raster. So with that set, I can go ahead and hit derive error surface. And once that's completed, it'll be automatically added to the map. I'm going to go ahead and that's here under error surfaces. I'm going to move error surfaces above associated surfaces so I can see that a little bit better. And that's that. It's up to you if you want to explore here and toggle it on and off to compare, to get an idea of what is causing certain things to have high values. or which inputs are causing the FIS to have high values. So you see how to do that. So I have a value of 0.48 meters. I have a point density of 0.08 and a slope of 13 degrees. Just a good idea to kind of get to click around and see how your inputs are interacting. So that's exercise N, part 1, running FIS error models. Be a good idea for you to save this. Again, underneath where we had the exercise. NFIS intro, FIS. Just gonna name this FIS part 1. Alright, in the next exercise, we'll be driving a 3-input FIS error model and then using those in change detection.